In this lesson, we'll talk about another rule for finding derivatives. And let's start by trying to find the derivative of each of these 5 functions. So pause the video and try to find each derivative. So on this one, it might help to rewrite it like this. And then we can see that we'll just find the derivative of sine, and that's cosine. So f prime is 1/2 cosine x. Here we have to be careful that we don't just find the derivative of each factor. We have to use the product rule, and that would be g prime. Let's write it out like this. We'll have the first times the derivative of the second plus the second times the derivative of the first. And we could just rewrite that, but there's nothing to really change here. We know that when we divide by a variable, we can't just find the derivative of the numerator and denominator. We have to use the quotient rule. And that looks like this. Where we go low, d high, high, d low, over low times low, low squared, the denominator squared. And that's the derivative. We can just rewrite it without parentheses. This one is, so some people, when they're not paying attention, might say, oh, it's a product and it's sine times 2x, so I'll do the product rule. Well, that's not correct because it's not a product. It's sine of 2x. So do we just do the derivative of this and the derivative of that? Probably not. So let's not assume and make up rules of how to find derivatives. And this is the type of function that requires the new rule, the chain rule. So we'll talk about how to do that. And this is called a composite function, where there's a function inside of another function. That's when we need the chain rule. Here we can just do each derivative separately when it's separated by, when they're part of it, when they are parts of a sum. The derivative of 3 is 0, and the derivative of sine is cosine. So let's talk about how to do that problem. And we can identify there's an inside function and an outside function. So the derivative is going to be, and this is the chain rule, we'll do the derivative of the outside, leaving the inside the same, times the derivative of the inside. And however you want to memorize that, whatever mnemonic you want to create, go ahead. If we write it in generalized form, and we had a function f that is a composite function of g and h, then the derivative of f is g prime of h times h prime. All right, let's try that. And We have to identify inside and outside. So let's look at the derivative of the outside. Well, that's going to be multiplied by 4. That's using the power rule. This is the derivative of the outside function, leaving the inside the same, times the derivative of the inside. All right, and find h prime with this one. Pause the video. So we're going to go, here's the outside and here's the inside. So the derivative of the outside, we multiply by 5 and subtract 1. Let's leave the inside the same, times the derivative of the inside. So the derivative of this is 6x squared. And the derivative of this is 1. And we're done. Okay, and here's just another just review of derivative notation. This means the derivative of y with respect to x. And we could have also written y prime. All right, so we need to identify the outside and the inside. The derivative of the outside, leaving the inside the same, times the derivative of the inside, 2x, and then we could just put it as 2x cosine x squared. All right, find the derivative of that. Pause the video. And if we identify the inside and the outside, that might help. Derivative of cosine is negative sine, leaving the inside the same, times the derivative of the inside, 12x cubed. Okay, and then we have to remember what this notation means. It means sine squared. So if we rewrite it and show that sine is the inside and squaring is the outside, then we can see how to find the derivative. We'll do the derivative of the outside, leaving the inside the same, times the derivative of the inside. Alright, and pause the video, try that one. Find the derivative of g. So that means the same thing as tangent cubed. And now we see the outside and the inside. And we'll multiply by the we'll do the power rule used on the 3, or the outside, leaving the inside the same, times the derivative of the inside, which is secant squared. It's okay to leave it like that. Alright, we'll just find a few tangent line equations and we'll be done. So we have to find the slope of the tangent line, and then we have to find the equation of the tangent line. The slope is the derivative, and we have an outside and an inside. We have a composite function, so we have to do the derivative of the outside, leaving the inside the same, times the derivative of the inside. You could write it as 6 2x plus 3 squared. We need to evaluate it at -1. Y prime when x equals -1 -2 plus 3 is 1, squared is 1, times 6 is 6. And then we'll do point slope, m, x minus x. We need the y value when x equals -1. And if we put a -1 here, we'll have 1 cubed, which is 1. We have the equation of the tangent line. And pause the video and find the equation of the tangent line. We'll find the slope and then do point slope. We have an inside and an outside, so it's composite. We need to use the chain rule. So the derivative of the outside, leaving the inside the same, times the derivative of the inside, 2x minus 1. And we just need to evaluate it, so we won't simplify. Let's evaluate it at 1, 2, 1 minus 1, 1 squared minus 1, 2 times 1 minus 1. So that's going to be 0. Y minus y, 0, x minus x. Slope and a y value, or x value. We need the y value at 1, If you put a 1 there, 1 minus 1 is 0, and we end up with y equals 0 for the equation of the tangent line. Okay, pause the video and try this one. And we have outside and inside. So we'll do the derivative of the outside. That's negative sine, leaving the inside the same, times the derivative of the inside. And let's evaluate it at pi over 4. F prime of pi over 4. And that's pi over 2. Sine of pi over 2 is 1. And the slope is negative 2. And then we do the point slope formula. M, X, and we need Y. The Y value when X is pi over 4, so if you put a pi over 4 there, we get pi over 2. Cosine of pi over 2 is 0. We get the equation of the tangent line, and we'll stop there.